here. I'm going to get started as unfortunately I have a hard stop in 35 minutes from now. Yeah, thank you very much for joining here. I have about 30 slides to show you, so I'll try to work through them smoothly so that we have ideally 10 minutes of Q&A. Feel free to put your questions in the chat. But yeah, feel free also to come on screen and unmute and let me know if there's any pressing questions during the presentation as well. All right, I'll get started. So my talk is about innovation being applied and envisaged at SQM's lithium operation in the north of Chile. You see a picture here from the Salar de Atacama on the ground, and I'll try to give a little bit more context on the area where we operate as well during the presentation. Let me see how to move my presentation forward. Okay, so I'll skip this one, but read it please if you want to invest in SQM. Then somebody mentioned, I think it was the person from crew, the low EV adoption rates. And I like to visualize that because in the media, you typically see the sales percentage of EVs on the total new car sales. But if you look at the total car park that's out there in the world, really there's a lot of work left to be done. Norway and China are some of the leaders out there. If you look at the EU and the US, we are with penetration rates of electric cars, plug-in and full battery of well below 5%. So there is a lot of work left to be done if we want to fight global warming. Then a quick slide on SQM. So we're not just the leading lithium producer in the world, we're also the leading producer of iodine in the world and of natural potassium nitrate. The potassium nitrates, potassium actually also comes from the salar. So we're one of the few operators on a salt lake that is actually producing more than one product. And this is relevant when I come back to the work we're doing on DLE. So I'll come back to that. Then this is a quick view of our pond systems. So you see here the heart of the nucleus of Salar de Atacama. It's a huge area. So the nucleus heart is 50 by 80 kilometers. I apologize, I don't know that in miles. I do know it's the size of a Belgian province. So if you want to go from one side to the other, it can take you more than an hour, as you can't drive very fast there. So in the back, you see the Andes Mountain. The perspective is a little bit confusing, but the Salar is at 2,300 meters above sea level. The mountain peaks of the volcanoes that you see in the back go well above 5,000 meters, some of them. So it's it's a really beautiful, impressive piece of nature. And so that immediately points to our responsibility as operator there to make sure that we work with the least impact possible and with respect of the environment and the people who live there, and all the resources we use. So here we then, I give you a quick view at the map of Chile, centrally in the slide. Then on the left, you see the north of Chile, the zoom in, and the location of Salar de Atacama. I'm showing that to highlight also the orange dot, which says Carmen next to Antofagasta port. So that's where we operate our refinery. We operate the single biggest lithium refinery in the world. It's by far bigger, I think at least 3 times bigger than the second biggest refinery in the world for lithium carbonate. We also produce lithium hydroxide there. And so this is very important because the perception is often that lithium is concentrated in the world. And I think the reality is much more, I'm not finding the word, but the reality is far from the perception sometimes. Then on the right, you see another view of the Salar de Atacama Basin. I show this to make you understand very quickly. It's a complicated topic, but very quickly the issue of the water. So local communities live on the east of the Salar, on the side of the Andes Mountain. You can see these black lines coming down from the mountain. Those are small canyons that channel the water from the snowmelt down into the Salar. Then you see this gray area on the east of the Salar. That's the alluvial fan area where the water infiltrates underground. This is where SQM has 4 active water wells. And then you see the white area next to that on the eastern border of the salar. That's the mixing zone, where the fresh water is pushed back out because of the heavy density of the brine in the nucleus. And then you see also our ponds on the southwest edge of the salar. This slide, I'll not go into too many details. It's based on data from the Chilean Copper Institute, Cochilco, collected from academic papers. Just want to highlight why Salar de Atacama is such a good, if not the best, lithium salar in the world. Has by far the highest lithium concentration, significantly higher than the number 2 and all the other salars. Also the highest potassium concentration. Then it has a medium magnesium to lithium ratio. This is very important for your refining efficiency. We have a high evaporation rate as the wind comes typically from the west to the east because of the altiplanic area warming up faster than the lower areas below. It's a relatively big salar at low altitude, which means it's accessible. We are in the north of Chile, which is one of the most important production sites for copper in the world. So it's a mining hub. So we have access to utilities, infrastructure, services, and all that you need to run such a big operation. I will not go into the process, but we basically precipitate several salts by evaporation in the ponds, and then you end up with the green yellowish liquid at the end, which is concentrated lithium chloride. The green color is not from the lithium, it's coming from the boron impurity. And then once the brine is concentrated to up to 35% lithium chloride, naturally present in the brine, or 6% lithium element, then the brine is moved in trucks to the refinery near Antofagasta. So this is a little bit older photo, but so this is what is now the biggest lithium refinery in the world, with a production of or sales of 200,000 ton last year. The process is relatively simple, but not easy. So you first remove the boron by a solvent extraction process, and then by filtration you remove magnesium. You react the lithium chloride with soda ash, you obtain lithium carbonate, which you then further process or use to convert into lithium hydroxide. And then from Antofagasta port, we ship all over the world. But the reality is that more than 90% of what Chile exports as lithium goes to Asia, which is an important fact because it means that in spite of all the noise about lithium in Europe and in the US, the fact of the matter is that from the perspective of a lithium producer, Europe and the US represent about 3% of global demand each. And so I think the first challenge for Europe and the US is to get the business case for localized battery production, then for localized cathode production. And that's the time when lithium producers can also localize near to those factories. Then switching to the topic of sustainability. So we take a very holistic approach to sustainability. We have actually, we worked with McKinsey back in 2020 to go through all of our operations and help us to prepare our sustainable development plan, which sets forth ambitious reductions in carbon footprint, water use, brine extraction, waste reduction. We're part of a number of initiatives relevant to this value chain. I won't talk about all of them, but just to mention that we are, I believe we're the only lithium producer included in the DJSI Sustainability Index World. And then we're one of 3 lithium producers to have undergone an IRMA audit. Today, we're still the only production site that achieved IRMA 75. Having said that, the other 2 sites also scored very well. And so overall, more than 40% of global lithium is engaged with IRMA in some stage of the audit process or the preparation for it, which hopefully helps to demonstrate to our stakeholders that we take this very seriously and we try to operate to the highest standards in the world of mining. I'll go quickly forward. We try to be transparent. And so one of the things that we have done to ensure that is that the environmental monitoring system, which in a reduced form is in place since 1997, in its full form in place since 2006, is transparently available with historic data at www.sqmsenlinea.com. and you can track the levels of the brine wells, showing the brine levels in the salar, the water levels, both in the lagoons and next to the salar. And then there's a lot of biological metrics as well. And we do this to allow people to check what we do and ultimately, hopefully, achieve accountability, which is a necessary condition before you can generate a trust with all your stakeholders. I'll not dive into this slide, but this is our ESG scores. I'll jump immediately to carbon footprint. So this is a slide coming from Benchmark Minerals Intelligence about their lithium ESG report. It's a buying report. But I wanted to share with you this slide, which shows that SQM is the lithium producer with the lowest carbon footprint in the world. That doesn't necessarily mean that we have the site with the lowest footprint, but other sites may then be much smaller. And overall, we are the operator with the lowest footprint. It's important to assess footprint because you cannot manage what you don't measure. And so this is basically a tool for us to try to iterate on our carbon reduction goals. This is obviously a responsibility of the whole value chain. And I always stress here that this is not a static state. This is dynamic. And so a lot of lithium operators are working towards lowering footprint. And that is very important because this is what the electromobility is needed for. And so we need to be aligned with that value chain. I wanted to share another slide. I'll not go into details. This is based on work we did with Argon. Their LCA model is open source, so everybody can go there and see the data for themselves. But it shows two types of batteries, medium nickel, high nickel, one coming from lithium carbonate from Salar de Atacama, the other one coming from a Chinese converted lithium hydroxide based on Australian spodumene. The lithium footprint is at the top of the bar each time in celeste blue or dark blue. So you see that NMC high nickel batteries have a higher footprint from the lithium, but then they have a little bit higher energy density. But so footprint matters. And again, here we try to show this to show that we're accountable and that we're working on reducing that very actively. We're almost 5 years into the launch of our sustainable development progress. So people often ask me, what have you achieved? What are results so far? And so we are now operating 37% below the allowed extraction rate of brine at just over 1,000 liters per second. We have operated at the full 1,600 liters per second prior. So these are real reductions. For the water that we use in the basin, we're allowed to extract 240 liters. The last 5 years, we have consistently operated at less than half of that. Our ultimate goal here is to stop using water in the basin, also to try to reinject more brine. This is a long-term ambition, so post 2030. But if you then combine the expansions at the refinery, so we have in that same time period that you see here on the right, we have effectively more than quadrupled our output and sales. So if you combine the increased output with the reductions, then the perceived water intensity of the lithium we produce has been reduced by 3/4. This is the typical way stakeholders assess us. So that's why I show it. This is not the way that we assess ourselves. So we very firmly follow LCA because that is comparable. And you have to allocate water between lithium and potassium because stakeholders typically allocate everything to lithium. And that is simply not correct because that would mean our salespeople for potassium chloride and potassium nitrate could argue that they don't have a water footprint, which obviously would not be correct. We don't want to stop here, and following our sustainable development plan, we presented 2 years later our innovation roadmap. So how can we make our lithium operations future-proof, and how can we really become the most sustainable lithium producer in the world? So we're working on 3 pillars: improving the efficiency, so to obtain more brine, more lithium from less brine, minimize water usage in our operation, and continue to decrease our carbon footprint as well. So one of the technologies that is obviously of high interest to many people in the lithium world and the battery value chain is DLE. DLE for us is not sufficient, as we cannot work with a technology that would only recover the lithium. We need something or a combination of technologies that also allows us to continue to produce potassium from the brine. But I wanted to share this slide from ID TechX because it shows very well the different technologies that are available to improve processes. And so what you mostly see is adsorption and solvent extraction or ion exchange, but membrane technologies are also very, very promising. And there is also electrochemical and chemical precipitation processes as well. So we have very recently given an update on our innovation roadmap. And so this is based on the study of more than 500 different brine wells to understand the brine, the heterogeneous and the dynamic nature of brine. We have explored and evaluated more than 140 technologies to optimize the way we extract the lithium. And we have completed 12 pilots in Chile and abroad. So based on all that work, which has been ongoing for many, many years, what we envisage is to combine different technologies. So the first technology is nanofiltration or membrane filtration, which we see the opportunity to apply it in different parts of the process, and that could be both in the salar or in the refinery. We want to combine this with mechanical evaporation. We will continue to need some water in the salar, and that is to clean pumps from the salts that crystallize when they come above ground. Also, the pipes need to be cleaned. And so what we envisage is that the water that we would use there would be water recovered from the brine in the mechanical evaporation, which would crystallize potassium salts. And so that's kind of like a combination and a win-win there. And then if we want to increase the recovery, the yields from the operation further, then we need to incorporate the elite technologies. However, we have always explained to stakeholders that adding technologies has a cost, and then there also needs to be incentive in the market. So unless we find some technology that is lower, as Ken actually mentioned in his presentation. So there we have not publicly announced yet what this will be, but we hope to submit our environmental impact assessment process or start it in the course of next year. So stay posted. Then this is another slide just to visualize a little bit where the communities are and how many people live there. So the last census was 11,000 people. Today is probably closer to 13,000 people that live around the salar. You see these green specks, those are oases in the desert from the water coming down. And so that's where indigenous people have typically settled. There's about 1 in 2 people that identify as indigenous. 1 in 3 is Licanantay, which is the ethnicity originating from the Salar de Atacama. But there's also a lot of people there that are not ethnical, working in tourism or working in mining. And so it's a diverse community. And we try to work with all the people that live around all our operations. Obviously, we focus on the 5 communities you see on the east because they are considered by the environmental permit that we currently work under as being in the direct area of influence. And you can see the wells are located close to them. And so that, of course, is our first focus, but we try to work with everybody that is around our operations. The lithium produced in Chile is state-owned because it's in the constitution that only the state can concession lithium. So even if you have a mining concession, you could extract everything else from the concession, but you could not extract lithium or commercialize lithium unless you have the express authorization from the government. This has allowed Chile to significantly increase the value sharing coming to the state and to the regional stakeholders. And of course, as lithium prices then peak, because we pay a progressive lease rate, prices go, the value sharing becomes big very quickly. So in 2022 was more than $3 billion, and 2023 was just under $2 billion. It has now come back down in line with the years before. However, the volumes we are producing last year was around 200,000 tons. So the volumes keep increasing, and that, of course, also improves the value sharing. Then I wanted to talk to you about what do we do to work towards a social license to operate. So one of the important initiatives that we did was to undergo an IRMA audit. I wanted to show you why we believe the IRMA audit process is the most robust and the most rigorous mining assurance standard in the world. So I show you a slide. This is public. This is from a report from Mercedes, which elevated and evaluated several standards out there. And so IRMA was a standard that achieved the highest score. It's not perfect yet in their view, so it still needs to step up in the complaints mechanisms and the effectiveness control, but it's well on the way to be what we would kind of consider the ultimate mining standard, even though, having said that, that still doesn't guarantee you a social license to operate. The way you can work towards that is by really being present on the ground in an active dialogue and working with the local people. So our operations site has achieved IRMA 75. What does that mean? IRMA has 4 chapters. So it's basically E, S, and G, environment, social, and governance. And the 4th chapter is planning and managing for positive legacies. So you can see our scores in each chapter. And then we continue to work towards 100%. This is a very, very tough standard. So we are not sure we will ever reach 100%, but we continue to work for that. Then last couple of slides on the lithium market. So we foresee a demand of around 3 million ton for 2030. We have always been conservative. There were forecasts out there with more than 4 million ton. I think our conservative view is now much more in line with what will actually happen. But I wanted to draw your attention to the graph on the right. And this was also mentioned in the previous panel. So we continue to debate in Europe and the US about should we drive combustion cars? Will it be the ultimately electric cars? Will it be something else? But if you look at China, 96% of EVs are sold in China with significant penetration rates. Many EVs are already cheaper in China than combustion cars. So that decision has been made. We need to go with the program if we want to have automotive and electric car production and battery production, cathode production diversified globally. Otherwise, it will go towards an Apple scenario. I'm not saying which is better or worse, but choices need to be made if you want to make something happen. Then another slide. So this is lithium from the lithium producer point of view. So NMC batteries, even though some use carbonate, typically the higher energy density ones and the high nickel one use lithium hydroxide. LFP almost exclusively uses lithium carbonate as feedstock. And so if you look then at where is the lithium demand in the world, so China is the big part of where batteries are produced today. And then more than 80% of what is produced in China uses lithium carbonate as feedstock. And that is completely different from the battery production outside of China, where if you look at South Korea, which still has significant battery production there, more than 80% is then using lithium hydroxide, and the rest of the world is roughly 30%. But as a lithium producer, this is really crucial because you invest in the capacity of a specific chemical. And so you need to get your capacity expansion plan right. And so we have teams working nonstop to anticipate this. This is a slide where lithium is produced largely today. I just wanted to highlight that in Chile, we refine most of, if not all of the lithium that is produced locally in Chile to lithium chemicals that are then mostly directly applied in our customers' processes. We don't have intermittent refining except for our lithium sulfate production, but that is a smaller part of what we do. This is very different from the historic way that lithium is produced from hard rock, typically coming from Africa or Australia by majority, where concentrate lithium ores are then sent to China, typically to be further converted and refined to lithium chemicals. And then final slide, I often receive the question, so who is the #1 lithium producer? Who are the other producers? This is another slide from the benchmark report. I cannot share with you the other producers, but I can confirm to you that SQM is, according to benchmark, going to be the biggest lithium miner and the biggest lithium refiner in the world this year. And then the final slide, this is from our investor deck. It shows our quarterly sales volume. It also shows the price evolution, shows where the lithium goes to, our estimated market share for 2024, some comments of how we see the market. This is where we operate or going to operate. CapEx for 2025 is 750 million. So we continue to invest, if a bit lower than previously anticipated because of the down cycle in the pricing. But we are very confident on the future of lithium. And so our ambition is to continue as lithium leader. So thank you very much. I'll now open the floor for questions. Be free to ask me any questions. And if you have more questions afterwards, you can also copy me or our team. Thank you very much.